All right, well, appreciate you guys attending this session here. Appreciate the Global Petroleum Show for giving us an opportunity to present the medium voltage heating technology. We believe this is a pretty revolutionary technology. It's going to revolutionize our industry and something that our heavy industrial users, oil and gas, petrochemical, are going to find very, very helpful for maximizing their efficiency, their profitability and sustainability in their plant as they go forward. So just to give an introduction, the electric heating industry has been around for 100 years. We've got a unique set of benefits that come through with electric process heating. Things like clean operation and efficiency. So electric heat doesn't have emissions, is not using fuel-fired systems. A lot of the clean needs that are out there today are benefiting from things like electric process heating. Lowered safety concerns. You don't need an operator to operate fuel-fired equipment, for example, and some of the special needs there. Minimal maintenance, no moving equipment with electric process heating. And so it's very long lasting. We have systems that have been out there for 10, 20, 30 years operating in place and process. So very minimal maintenance. And then controlled costs, although the cost of electricity is higher than natural gas as a fuel, for example, clearly a lot more stable when applicable. And then accurate temperature control as far as turn-down ratio and what it can do in your process for variability of temperature control and efficiency. You basically pay for and use exactly what you need, as opposed to turn-down ratio as an example for fuel-fired equipment and that loss of efficiency if you turn down and not running at full capacity. So those are the benefits that the industry's seen for the last 100 years for use of electric process heating. And typically, basically electric is your fuel source in a sense, right? And so you're familiar with this diagram, won't go through it too long, but basically the power generation facilities generating power, they're stepping up the transformer to transmit it over long distances at high voltages. And then as it approaches the need for the industry, it's stepped down with substations to medium voltages and then down to lower voltages. So for the last 100 years, process heating with electric has been done at low voltages, 480 volt, 240 volt, up to 600 to 690 volt. And so all those benefits come at a little bit of a cost when you start getting to a lot larger systems due to amperage size, complexity of installation, etc., when you're pulling a very large heat load. And that's where medium voltage comes in. This brand new technology enables you to run much larger systems that before may have been a limitation due to, again, installation costs. The size and scope of bringing that electrical to the source is now minimized with medium voltage, whereas before you'd have to deal with that at low voltage. So now, not only do you get lower install costs, maintenance costs, operating costs through medium voltage, which we're going to walk through here in a little bit, you also get the benefit of thinking outside the box, and so utilizing it for new applications, larger systems going forward. We've seen this in the industry for the last 5, 10, 15, 20 years. The industry, oil, gas, petrochemical, is demanding larger and larger systems, and these are the difficulties they're facing with installation. So medium voltage is the technology that enables you to finally do that. And so we thought the best way to do that would be to walk through just a case study and talk about just walk through those cost savings and installation savings and how this benefits the industry. So in this case study, Refinery installed a relatively small system for medium voltage, just 2.5 megawatt approximately. And you can see here, this is the low voltage situation. If they were using the traditional technology that the industry used for 100 years, you'd be operating 2.4 megawatts of power. You'd provide obviously the process heater, the SCR control panel. They're obviously going to need, in that kind of capacity, to install a substation or use a local substation and transformers to step down the power and pull significant amperage for that process. And so here's just a quick case study of what those costs would be for the capital equipment of the heater, the panel, and then the substation and installation of just the heater itself. And this is where medium voltage really kicks in. So the cost drivers of installation that are high when it comes to low voltage systems would be things like the transformer. Most systems in a plant are going to be sort of at capacity. When you introduce a new heating process that may require multiple megawatts, most likely they're not going to have the power available. Bring in the substation or add capacity for that load. And when they do that, they're going to need transformers again to step it down. So that's a significant cost savings to apply that heater in that application. Cabling and termination. For that kind of amperage we're talking about, significant amount of wiring installation costs that are very, very, very large and time consuming from a labor perspective. And then just installation itself and concern with how that's done correctly. Like I said, minimal maintenance, no moving parts, but at the same time, you've got a lot of electrical connections and a lot of power being drawn. You need to be concerned about that and how you manage it. What it comes down to basically is Ohm's law. It's always Ohm's law. And so in a typical low voltage situation, in this case study for 2.5 megawatt at 480 volt in this case for this customer, you're pulling almost 3,000 amps and 24 circuits of power. That's a cost that they have to consider beyond just what the capital equipment is for the heater and the panel and the control system. You can apply the exact same application, that exact same process at medium voltage, and suddenly you reduce down to just a few hundred amps and minimal circuits and eliminate the transformer. The installation cost reduction is tremendous. And we're talking about just a 2.5 megawatt load. These systems are capable, obviously, of much, much larger than that. And so here's a side-by-side comparison of those cost differentials. This is a no-brainer. At the end of the day, when you look at the incremental cost for the equipment, you're making it back easy before you even finish the installation. It's a no-brainer. So we really believe that this type of technology, like it did for motors and high horsepower systems back 15, 20 years ago in that industry, is going to change our industry as well. And so you see right here from the installation, before they even got the plant up and running, they saved $250,000 on their project from this technology. And at the end of the day, I just like this picture because it really puts graphically the words I'm talking about. On the left there, you see the a 10 megawatt installed system, process heaters and control panels, SCR control panels. A lot of equipment, a lot of time. To the right is just the transformers that this 10 megawatt system to run. Okay? They're bigger than the heater and the panels. They're more expensive. And the time it costs again to wire this up and install is tremendous. With this medium voltage technology, everything on the right goes away. With Chromalox's direct connect technology, you connect right up to the power substation at medium voltage. And so again, it not only saves you money and time on existing applications, but it really opens up the door for new applications that maybe you haven't thought of before in process and industry. So we're real excited about seeing how this is going to change in the future. Now this information, if you want to write this down, just some quick information about some cost savings, just kind of rules of thumb to give an idea of what it could be in a given installation. And this is available on our white paper and a case study on the website. So for example, on the equipment savings alone, by reducing or eliminating the transformer, you can save about $7,500 per million BTU hour installed. As far as the installation costs, again, about $1.50 per amp per foot. So you've got a significant run line of your power from the source or from the panels in the heater. That can add up pretty quickly, especially in these large loads. And then finally, labor savings, up to 80%. When you're talking about going from 24 circuits and maybe hundreds of cables down to just a few cables and a small size at that medium voltage, tremendous savings in install time and cost for your contractors and the people doing the install work. And so these are some rules of thumb you can use when you're evaluating your projects and looking at it in your plan. But it just doesn't stop at installation either, though. There's also tremendous savings in operation as well. So for example, the most common thing we deal with other than moisture in our industry is the connections, the installation of all those connections. And so, as you know, with electrical connection, you've got to have a good connection. It's got to be solid and firm. And otherwise, you're going to increase your I²R losses through the system anyway. And you might have obviously a risk of burning out a loose connection where there's that amperage going through there. And so when you have a large system like this, that's a major, major concern. And so the potential cost avoidance for a system like this in the field with medium voltage, it minimizes those cables and reduces that size and scope, is pretty significant. In addition, why do power companies step up the voltage when they transform it over miles and miles and miles? Because it's more efficient, less line losses in general. Well, that's even true on a small scale. Even in a local plant, going from your power feed to the installation, switching from low voltage to medium voltage saves you several percent in efficiency of those line losses. And that adds up over time. Every second this is running, you're going to reduce your cost of operation. And then finally, the same benefit you get from low voltage installations for electric process heating, you obviously get at medium voltage. You apply SCR or thyristor control, you can dial in exactly the power you need. So if you need 50%, 25%, 17.5%, that's what you're going to use and that's what you're going to draw. Unlike, again, fuel fire systems. And so that's where, again, these larger loads, maybe it starts to make sense in looking and evaluating electric versus other fuel sources. And then as far as maintenance and life cycle costs, again, the same advantages you get from low voltage situations you get at medium voltage. But again, lessons due to the number of circuits, the lengths, etc. And so the maintenance time is greatly reduced. And then finally, this is where the sustainability comes in. If you start to apply this technology, to larger loads and systems that maybe hasn't been used before, you now start to hit on topics and issues that are relevant to plants today in the environment. So what's a concern for facilities out there? Emission control, right? Emission reduction, maintaining equipment, maintaining operators that can run and are certified. A lot of that's eliminated when you go to electric process heating. And so instead of just doing it at the lower, point of use type systems, as the industry is demanding more and more larger systems, now suddenly medium voltage enables you to do that and save that time, that money, that permitting, all the hassle associated with that, and emissions control. Those all are eliminated with electric systems. And so at the end of the day, when you really add it all up in this real case study for a real customer, what you tend to see is significant savings. These heaters, like I said, typically when manufactured correctly will run 10, 20 years plus. And so over the life of the product, you're seeing $1 million in savings. And this is just a 2.5 megawatt system. We gave you a very reasonable, simple case study, not even talking about those kind of savings over much larger systems. And so we really believe that, again, the medium voltage technology is a game changer in our industry. Finally, I like this graph. Where does it apply? You might want to think about where it applies. Well, it doesn't make a lot of sense for smaller systems. Smaller systems, you just aren't going to make that money back in operation installation costs versus the capital equipment of supplying medium voltage. And so that kind of makes sense. So where's the turnover tipping point? Well, right around 500 kW up to 1 megawatt. That seems to be the crossover point. Again, it depends on your installation situation, how you're running, how much line you have, the distance, etc. All those factor in. But certainly once you get over 1 megawatt and beyond, it's pretty much a no-brainer. It's pretty much a no-brainer. At that point, the cost savings far outweigh the capital equipment up front to the point where you're literally making it back before you even run the heater. So really tremendous stuff. Finally, just to give you a kind of a highlight of where this type of technology is used in industry today. If you're not familiar with it, these elements and these systems are used for flow-through circulation situations, oil, gas, water, just about any type of fluid you imagine we heat in our industry. We also have steam boilers and vaporizers. This is an area where I think could be very beneficial to the industry, thinking about vaporization, oil and gas, and for steam boilers. Bringing those large plant systems down, moving to the high capacity electric boilers, point of use, in location, minimizing all the hassle dealing with steam systems. I mean, really tremendous stuff that it opens up as far as your capabilities go. Heat transfer systems, the case study we gave you was actually a hot oil system in that particular case at a refinery. Hot oil systems, again, are typically getting larger and larger in scope, and so to move that to electric is a really good idea and an option, especially if these facilities are at their permitting levels, they're at their emissions levels, they can't really add any more, they don't want to go through that process. It's a great addition for new capacity and new systems that might be needed in the plant. And then just about any type of other package system available as well. And so this is where these medium voltage electric heaters can be used and made it advantageous to your application. And so in the oil and gas industry, there's a ton of applications. I just listed a few. Not going to run through this, but clearly there are thousands and thousands of applications. The industry's been around for 100 years. Pretty much all of your major markets, all of your major applications, if it needs heat, it's probably been done electrically. And so this opens up, again, a whole new area, not just for what's been done before in larger capacities, but also just giving you new ideas for how to apply this in different ways in your plant. And so we're, again, real excited about this technology and what it has to offer. And so with that, appreciate you listening to the conversation here. If you need any information about the technology and what's out there, please visit our website, pull down the white paper, look at our information. And again, we appreciate your time and listening. Thanks.